Welcome members, in today's lesson today we are going to see how do we determine the nature of quadratic equation roots of a quadratic equation. Now, we know that the quadratic equation, the general equation is ax squared plus bx plus c equal to 0. Now, if you use the bulldozer, this is how we state the formula for getting the roots of this equation. Now, this one is what we call the discriminant. Now, it's always this discriminant that is going to determine the nature of those roots. Now, if the discriminant is greater than 0, we mean that we are going to get real distinct roots. If the discriminant is equal to 0, if the whole of this is 0, we are going to get repeated roots. Repeated roots. If the discriminant is less than 0, we mean that if it's negative, less than 0, if it's negative, we are going to have complex roots. If they don't call them complex roots, they call them unreal, stroke imaginary roots. Now, the example I have here, determine the nature of roots of the following equations. Now, from here always, we need to use our discriminant, this one. So this is our discriminant. Now, of course, we need A, B, and C. We compare using the general. So from the general, our general is ax squared plus bx plus c equal to 0. So start from here. My a is 3, my b is a 5, and my c is a 2. So now if we set the discriminant, b squared minus 4ac, I want to know what is it giving me. My b is here as 5 squared, then minus 4 into 3, then 2. And this will be giving me 25 minus, this is 6. 3 times 2, 6 times 4, that's 24, and you start up, so you get 1. And this one is positive, meaning it's greater than 0. And if it's greater than 0, so now our discriminant, b squared minus 4ac is greater than 0, meaning that we have real distinct roots. So this equation is going to give you your distinct roots. When I come to this one, if I compare that my a is 1, the coefficient from here, my a is 1, my b is negative 4, then my c is a 4. So putting it in, so my b squared minus 4a is 2, a is 1, then c is 4. So this will give me 16 minus 16, which will be a 0. So start now, my b squared minus 4ac is equal to 0. And if it's 0, we said now this equation is going to give you real repeated roots. So when I come now to this one, if I compare, start from here, my a is a 1, my b is a 3, and my c is 8. So if I put in this square, the discriminant for AC, I have now into 8. This will give me 9 minus, this I think is going to be 32. And when you subtract this from this, I think you get 20, negative 23. Now, it's like this one, it's less than 0. So b squared minus 4ac is less than 0. What does it imply? It implies because it's negative, that's why you say it's less than 0, because it's negative. So the roots we are going to have here are going to be complex roots. So the nature of these roots of this equation are going to be complex. If I end with this, we start from here. My a is 4, my b is negative 4, and then my c is a 1. So you can still put into b squared minus 4ac, so the b squared will be negative 4 squared, then minus 4 into a 4 into a 1, which will give you still 16 minus 16, which will be 0. So these roots are going to be repeated roots. So that's how members will determine the nature of quadratic equation, the nature of roots of a quadratic equation. Please don't forget to subscribe to the channel. I wish you the best.